Assalamu alaikum wa rahmatullahi wa barakatuh. Dear students, hope you are fine with the grace of Almighty Allah. Dear students, yesterday we have discussed magnetism and certain things that are related with the magnet. Let us give a brief revision of these things what we have yesterday learned. As you know, the magnetism, it is that branch of the physics that deals with the magnets and their properties. We also discussed that magnet is any substance that have the ability of attracting the magnetic substances such as iron, cobalt, nickel and steel. We also discussed that how this magnet was discovered. As you know that a shepherd was rearing his cattle or sheep, and suddenly his city that was having a metal tip get held by a stone, and after a long exertion he get released his stick. But he was certainly surprised, which things makes my stick to get stuck with the stone, and finally that stone was actually a black stone, and that stone was the magnet that we call a magnetite. And it is how that the magnet was discovered. But this magnet is having so much importance in our life. As you know that if we look in our home, we are using magnets. Indoors, we are using magnets. In several other things. For example, we have this drawer. When you open the drawer, there is a magnet. It gets automatically closed just by a slight push. Similarly, a door is having this magnet attached, because when we push it, we want to close it, automatically it gets by a slight push it gets closed, because there is a magnet. Magnet gets attracted with a piece of iron. There is that we fix in door. Similarly, magnets are used in refrigerators. They are used in fridges. They are also used in radios, transformers, we can say. These are used in our televisions, etc. So magnets have fascinated our life in different ways. As you know that magnet is having so many interesting things. As yesterday we discussed that if we have small piece of magnet but a regular magnet, regular means that having a fixed shape, such as we have taken yesterday a bar magnet, and when we suspend it freely, it aligns itself in north-south direction. The reason only how it aligns in north-south direction, its reason was that our Earth is a big magnet, and it was said by William Gilbert in 1600. Now we today know that Earth is having a magnet, and Earth is actually we can say biggest magnet. It is because of the Earth's magnet that this small piece of the bar magnet gets aligned in north-south direction. And we say the north pole of this magnet shows the north side of the Earth, that we call the geographical north of the Earth, and south pole of this magnet shows the geographical south of the Earth. But how this magnet aligns itself in north-south direction? It is because of the magnet of the Earth. The Earth is having also the poles, north pole as well as south pole. The north pole of the Earth actually, the north, it is not geographical north, but actual north side of the Earth, as Earth we take is a magnet, and then the north side of the Earth will get attracted by the south pole of this bar magnet, and the north pole of this bar magnet gets attracted to the south pole of our Earth. And this is what we have read yesterday, that the important properties of a bar magnet. One of the property of the bar magnet is it aligns itself in north-south direction. The only reason is because of the magnet force of the Earth. Earth is having a magnet force. Earth itself is the biggest magnet. So north, one of the property of the magnet is that like poles repel, unlike poles attracted. That is why the north pole of the magnet, bar magnet, gets attracted with the south pole. Actually, as when we consider the Earth as a magnet, it gets attracted with the south pole of the Earth. But this north pole of the magnet shows the north side, that is geographical north of the Earth. It shows the geographical north. That is shows north side of Earth. That will get its north side. But actual, if we see as Earth as a magnet, then that is the south. And when we see this, when we look here on this, this bar band, this is south pole. It gets attracted with the north. It will get attracted with the north. So this north actually is the geographical south. This north side of the Earth is actually geographically south, and this south side, that is south pole of the Earth, is actually north, that is geographical north. That's what we have yesterday. It is a property that like poles repel, unlike poles attract. This is how this suspended bar magnet aligns itself in north-south. It is the reason. Yesterday also we discussed that there is a force that is called a magnet force, and magnet force is the force which is magnet, that force exerted by a magnet. This force may be force of attraction, this force may be force of repulsion, as you know. The force of attraction, for example, unlike poles, for example, unlike if we bring two bar magnets, if we bring the north pole of one bar magnet to the south pole of another bar magnet, these two will get attracted. But if we bring north pole of one magnet towards the north pole of another, they will repel each other. So there may be two forces, force of attraction or there may be force of repulsion. So we say the force of attraction or repulsion, force of a magnet force, whether it is the force of attraction or repulsion. When it repels something or when it attracts something, this is called the force of attraction. The force of attraction or repulsion between two things, that it is between the magnet and non-magnet substance, or between the magnet and another magnet substance, this may be force of attraction, or that may be force of repulsion. If they go far away from each other, then there will be force of repulsion. If they come closer to each other, that will be the force of attraction. Depends upon whether it is north and south, or whether it is north or south. So this is the force of attraction. And the term that we yesterday discussed, it was about what is the magnetic field. What is magnetic field? We yesterday discussed that magnetic field is actually the space around the magnet up to which the magnetic force is influenced. Magnetic force. For example, this is north pole and this is south pole. Magnetic field is the space around the magnet. Magnetic field is the space around the magnet about which the magnetic force is influenced. ये वो फील्ड होता है, ये स्पेस होती है मैग्नेट के इर्द गिर्द जहां तक हम मैग्नेटिक फोर्स को इन्फ्लुएंस कर सकते हैं, महसूस करते हैं, मैग्नेटिक फोर्स. अगर हमने यहां तक महसूस किया मैग्नेटिक फोर्स, so this is the field. Then the space that is around the magnet के इर्द गिर्द जो स्पेस होती है जहां तक हम मैग्नेटिक फोर्स को महसूस कर सकते हैं, वो मैग्नेटिक फोर्स बन जाता है. Now today actually we are going to discuss that is what are magnetic and non-magnetic substances. Magnetic substances. First we write here magnetic substances. Magnetic substances are those substances. Magnetic substances are those substances which get attracted by the magnet. Which get attracted by a magnet. Those substances which are attracted by the magnet are called magnetic substances. For example, we have iron. Iron gets attracted by the magnet, and magnet itself is a stone that was discovered, that is called a magnetite, and it is named, the person who discovered that, his name was actually manganese, and after the name of the manganese, this stone was named as a magnetite. This stone is also known as magnetite. Its formula is Fe3O4. That is actually the formula. That is, it is iron oxide. This magnetite ore is iron oxide, magnetite ore. It is oxide of iron. This oxide, magnetite ore is the oxide of iron. Its chemical formula is Fe3O4. Remember this. This stone is also new one thing that formula. This stone is also this black stone. It is also the RVKC magnet. It is another name is that's called leading stone. The reason that we call the leading stone, its reason is that it shows direction. It shows north side direction. If any person lost his direction, so he can find his way by using this stone. This magnetite, or we can say the magnet. Certain mode, one of most greatest importance is that this magnet is used in compass. That is magnetic compass. That is used by navigators. Any person can use this for direction. So the compass that are used by navigators in order to find the direction. This is a compass. Magnet needle is here. This magnet needle aligns itself in north-south direction. The magnet needle होती है, ये खुद ही रहती है किसमें north-south direction में. It shows north and south direction. So navigators use this compass. So it is one of the most importance of this magnet. Magnets are using magnet compass. So we can find the way by using magnet compass. Magnet substitution, we'll go back. Magnet substitution, say that those substitutions will get attracted by the magnet are called magnet substitutions, and among them they are iron, for example, steel, it may be nickel or cobalt. These are the things that get attracted by the magnetic substances. These are the things which get attracted by the magnet, and these things are called the magnetic substances. And similarly, there are another substances that are called non-magnetic substances. Those things are those substances which are not attracted by magnet, If we bring those substances near the magnet, they will not get attracted. For example, if we bring wood near the magnet, can it get attracted? No, wood is not. It's a non-magnet. It will not get attracted by the magnet. So similarly, we have plastic. Here we write wood, plastic. We write here rubber. We write here cotton, wool. These all things are what? Non-magnetic substances. These are non-magnets. These things doesn't get attracted by the magnet. So these are non-magnetic substances. Another thing that is called, they actually give types of magnets. We have two types of magnets. One is called a natural magnet, another one is permanent magnet. What are natural magnets? Natural magnets and artificial magnets. Natural magnets are those magnets which are found in nature. Those substances which are found in nature, and they have the property of a magnet. As magnet have the property that it should attract the tiny piece of iron, cobalt, and nickel. The thing which is having this property will be considered a natural magnet, and it should align itself in north-south direction. And if we want to break this natural substance, but all those natural substances which are found in the earth, they do not have the regular shape. They have odd shape. So when we give them shape, then it will we can make them bar type. We can make them cylinder type. We can make them ball point, or we can make them horseshoe type. We can make them U shape type. So it depends upon also which type we want. But those things which we get directly from the earth or from nature, those have irregular shape. They doesn't have the regular shape. So what is a natural magnet? Natural magnet is that magnet which are found in the nature, and those things are, and those magnets have the same property as the magnet has. Those substances that we get from nature, once again, those substances that we get from nature, and they have the property of a magnet. They have same properties as the magnet have. Those things are called the natural magnets. I have given the example of magnetite. Magnetite is actually it's a black stone that is called leading stone as well, or we can say magnetite. Magnetite is a natural magnet. It have all the properties what the magnet should have. जो भी मैग्नेट की प्रॉपर्टीज होनी चाहिए इस मैग्नेट की सारी मैग्नेटाइट के वो सारी प्रॉपर्टी. So this is a natural magnet. Another thing is that is called artificial magnets. Artificial magnets. Artificial magnets are those magnets which are made by man. Those magnets which are made by man by certain processes. Those magnets are called artificial magnets. We can say the magnets which are prepared by man, which are synthesized by man, or simply which are made by man by certain processes, those magnets are called artificial magnets. I will give the example of electromagnet. For example, we have electromagnet. Electromagnet is the magnet which works on the electricity. Electromagnet is a magnet which works on electricity. For example, if you take the iron nail, just give an example of iron nail, or soft iron we have, and we have to wind this copper wire, but it should be insulated copper wire. When we switch on, here it is switch. When we on the switch, electricity flows through the wire, and this iron nail behaves as a magnet. If we bring small nails here, हमारे पास छोटी छोटी needles होनी चाहिए, iron nail या piece of nail होना चाहिए, कुछ iron की टुकड़ी होनी चाहिए. You will find that they get attracted. They get attracted by this iron nail, by this electron, and this becomes then electromagnet. This is an electromagnet. So this electromagnet is an artificial magnet. So this is an artificial magnet. But this artificial magnet is having certain types. इसके अपनी types. Number one type of the artificial magnet is temporary and permanent magnet. Temporary magnets. Temporary magnets. Temporary magnets are those magnets which have the property of magnet, which have the property as magnet have, but their property remains as long as the cause of producing in them magnetism is removed. As long as the magnetic induction, or we can say the cause of producing in the magnetism is removed, they will become non-magnetic. They will become non-magnetic, or we can say they lose their magnetic power. वो मैग्नेट नहीं रहते. फॉर एग्जाम्पल, सेम एग्जाम्पल, इफ वी टेक दिस इलेक्ट्रोमैग्नेट, जैसे हमने अभी आयरन ले लिया, जिससे आयरन ले, इफ वी वाइंड अगेन दिस कॉपर वायर हमें वाइंड करनी है, देन आफ्टर व्हेन वी स्विच ऑन इट विल अट्रैक्ट द आयरन पीसेस, स्मॉल आयरन पीसेस, इट बिकम्स मैग्नेट. बट इफ वी स्विच ऑफ, अगर हमने अब स्विच ऑफ किया, अब यहां से इलेक्ट्रिसिटी नहीं चल रही, इट विल लूज ऑल द आयरन पीसेस, दे विल लूज, they will get released from this. जो इलेक्ट्रोमैग्नेट अभी बना था, यहां से वो नीचे गिर जाएंगे ये सारे आयरन पीसेस. क्यों? क्योंकि अब इसमें इलेक्ट्रिसिटी नहीं, तो इट बिकम्स मैग्नेट एज लॉन्ग एज इलेक्ट्रिसिटी फ्लोज टू इट. जब तक इलेक्ट्रिसिटी इसमें चलती है तब तक ये इलेक्ट्रोमैग्नेट बना, ये तब तक मैग्नेट था. जो ही हमने इलेक्ट्रिसिटी बांध की, अब ये मैग्नेट नहीं रह पाया, तो इसने सारे जो मैग्नेट्स ने अटैच किए थे वो गिर गए. तो दिस इज नाउ, we can say this is not a magnet. So this is a temporary magnet. The magnet whose magnetic property remains as long as the cause of producing in the magnetism remains, or जब तक वो cause of magnetism removes यहां पे रहेगा, जब तक हम इलेक्ट्रिसिटी में फ्लो करेंगे तब तक ये मैग्नेट रहेगा. जो ही हमने बांध किया इलेक्ट्रिसिटी या मैग्नेट, सो दिस इज टेम्पररी मैग्नेट, दिस इज नॉट ए परमानेंट मैग्नेट. ये अपना मैग्नेटिज्म लूज करता है जो भी हमने स्विच ऑफ किया. सो दिस इज टेम्पररी मैग्नेट. Now, another one is that is permanent magnet. Magnet. तो ये जो इलेक्ट्रोमैग्नेटिक्स की बहुत ज्यादा इंपॉर्टेंस है. वी हैव क्रेन्स, हमारे पास क्रेन है, बड़े बड़े क्रेन है. तो दीज क्रेन्स आर यूज्ड फॉर some cranes that are used for separating the waste material in order to get magnetic and non-magnetic solutions. उनमें बड़ा सा इलेक्ट्रोमैग्नेट लगा हुआ होता है, ऐसा बड़ा प्लेट लगा, फैक्ट्री में ये हम इस्तेमाल करते हैं. इलेक्ट्रोमैग्नेट, बड़ा सा इलेक्ट्रोमैग्नेट क्रेन पे लगा हुआ, तो इसे क्या करते हैं, इससे सेपरेट करते हैं मैग्नेट वो नॉन मैग्नेट सब्सटेंस. ये ऐसे हम मतलब वेस्ट मटेरियल में ऐसे मूव कराते हैं, तो यहाँ पे जो भी मैग्नेट सब्सटेंस इससे एडहियर होती है. स्विच ऑफ किया तो डाला कहीं भी, ठीक है, ये वेस्ट मटेरियल मतलब जो भी इसमें मैग्नेट सब्सटेंस उनको एक साइड में रखेंगे, नॉन मैग्नेट सब्सटेंस को इसे अलग दूसरी जगह रख सकते हैं. तो दिस इज यूजुअली इन फैक्ट्रीज. तो परमानेंट मैग्नेट इज दैट मैग्नेट which have the magnet and its property remains as long as we can keep. And if we अगर हम इनको रिमूव भी करेंगे, अगर वहां से हम रिमूव भी कराएंगे the cause of producing magnetism, अगर हम इसको रिमूव भी कराएंगे तो still it will retain its property of magnetism. ये बिल्कुल अपनी प्रॉपर्टी और जो मैग्नेट की प्रॉपर्टी होनी चाहिए वो बिल्कुल इसमें रहती है. तो once again, permanent magnets are those magnets which can retain the property of magnetism as we remove the cause of magnetism. अगर हम रिमूव भी करेंगे cause of magnetism जो इनमें होगा, अगर इसको रिमूव, still they will retain their property. वो फिर भी में ये कैसे, फॉर एग्जाम्पल ये बहुत तरीके से हम परमानेंट मैग्नेट बना सकते हैं, या रबिंग से हम, या अगर हम किसी को हैमर करेंगे, किसी आयरन चीज या किसी चीज को हम हैमरिंग करते हैं, दिस प्रोसेस हैपनिंग बाय हैमरिंग और रबिंग सर्टेन थिंग्स एंड दोज थिंग्स बिकम देन परमानेंट मैग्नेट. उससे वो चीज क्या बनती है, जैसे हमारे पास एक परमानेंट मैग्नेट एल्निको एक्चुअली इज alloy of aluminum, nickel and cobalt. This is the alloy of aluminum, nickel and cobalt. This is a permanent magnet. जो भी alloys है aluminum की, nickel और cobalt की, these are permanent magnets. वो permanent magnets.